Hello guys, welcome to my YouTube channel. Today we are going to discuss about Python operators concept. Let us get started. If you have not watched my previous videos, please do watch them. I will provide their link in the description section below. Generally, operators are used to perform operations between two or more values or variables. In Python, the operators are broadly classified into arithmetic, relational, logical, bitwise, assignment, and membership operators. Let us discuss about arithmetic operators first. Addition, subtraction, division, multiplication, floor division, and the modulus. These are the operators comes under arithmetic operators. Addition, subtraction, multiplication, and division we already know. So let us focus on these last two operators. Here you can see the double division symbol, which we also call as floor division. Generally, the floor division returns the quotient when A is divided by B, and the modulus just returns remainder when A is divided by B. Let us see that with an example. Here we have taken the value of A as 10 and B as 3. Here you can see all the arithmetic operations: addition, subtraction, multiplication, and division. Let us focus on the difference between division and floor division. Here you can see the value of A we have taken as 10 and B as 3. When 10 divided by 3, here we applied the normal division operations. It returns the float value. When 10 divided by 3 with the floor division, it returns only the integer value, which is nothing but the quotient value. Coming to the modulus operator, modulus just returns the remainder when 10 is divided by 3. When 10 is divided by 3, the remainder is 1. So the modulus returned 1 as the return value. Coming to the relational operators, greater than, less than, double equal to, greater than or equal to, less than or equal to, not equal to comes under the relational operators. When relational operators are applied between two operands, it returns Boolean as the return value. True or false comes under Boolean values. Let us see the relational operators with an example. Here we have taken A as 10 and B as 3. A greater than B. Here 10 is greater than B. That is why it returned true value. Here 10 is not less than 3. That's why it returned false value. Here 10 is not equal to 3, so it returned false value. 10 is greater than or equal to 3, which is true. That is why it returned true value. 10 is not less than or equal to 3. That is why it returned false value. Here 10 is not equal to 3, which is true, so it returned true value. Coming to the logical operators, and, or, not comes under the logical operators in Python. Let us discuss about the nature of and, or. And returns true if both the operands on which it is applied are true. Or returns true if any one of the operands is true. Not returns true if the operand value is false. Not returns false if the value is true. Let us see the logical operators with the example. Here A is true and B is false. True and false, as both are not true, and returns false. True or false, as here the value of A is true. It satisfies the criteria one of the operands is true, so or returns true as its return value. A is true, not of A returns false. Similarly, B is false, not of B returns true. Coming to the bitwise operators, bitwise operators operates on the binary values, which are nothing but 0 and 1. These are the bitwise operators. These bitwise operators operates on bits. Let us see how these operations will work before going with an example. 0 and 1 are the only binary values. This first column corresponds to A value. This second column corresponds to the B value. Here A and B both are bits, which are nothing but 0 and 1. If any one of the A or B value is 1 or returns 1, You can see here both are zeros, that is why it returned 0. In rest of the cases at least one of the value is 1, so it returned 1. Coming to the AND, it returns 1 if and only if both the values are 1, otherwise it returns false. So OR operation between two bits returns 1 only if both the bits are different, that is if one operand or one value is 0, the other must be 1, or vice versa. If both are same values, it returns 0. Here both are zeros, that is why XOR returns 0. Here both are ones which are same, that is why XOR returns 0. XOR returns 1 only if both values are different. Let us discuss the binary operations with an example. By mistake I have written a equal to 8 here. Here a should be equal to 4 and we have taken b equal to 3. 4 in binary format will be written as 1 0 0. Now coming to the OR operation. OR operation returns 1 if at least one of the value is 1. Here in this case, here the value is 1, so it returned 1. Here one of these two values is 1, so returned 1. The same case here, so it returns 1 1 1. When we multiply with corresponding two powers and add them, it results in 7. So A or B, which is nothing but 4 bitwise or 3, results in 7. Coming to the AND case, AND returns 1 if both are 1. None of them have both ones here, so it returns 0 in every case, in every combination of these two. Coming to XOR, XOR returns 1 if both bits are different, that is one should be 0 and other should be 1. Here it is 0 and 1, both are different, so returned 1. Here it is 0 and 1, both are different, so returned 1. Similarly here it is 0 and it is 1, both are different, that's why it returned 1. When these are multiplied with corresponding powers of 2, we get 4, 2 and 1. When we add them, the resultant will be 7. Coming to the right shift and left shift operations. When we perform right shift on 4, this bit should be moved 2 positions to the right. When it moved 2 positions to the right, it becomes 0 0 1. When we multiply with corresponding powers of 2, we get 0 0 and 1. When we add them, we get result as 1. So when A equal to 4 right shifted by 2 positions, we will get 1 as results. Coming to the left shift case, similarly we have to left shift 2 positions here. When we left shift 2 positions here, the 1 in the third place will come to the fifth place. When it is multiplied with corresponding power of 2, which is nothing but 2 power 4, we get 16 here. So 4 left shifted by 2 positions will return 16. Coming to the bitwise NOT operator. Bitwise NOT is nothing but the ones complement of the number with a minus symbol in front of it. In ones complement, we add 1 to the rightmost position. Here 0 plus 1 returns 1. If here it is 1, 1 plus 1 should return 1 and 1 should be the carry here. Here as it is a 0, 0 plus 1 returns 1. Here 0 plus 0 returns 0, 1 plus 0 returns 1. When multiplied with corresponding powers, we will get 5 as the result. We should keep minus before it. So bitwise NOT of 4 returns minus 5 as the result. Coming to the assignment operators. Equal to is the basic assignment operator which we will be using to assign a value. For suppose a equal to 10. Here we assigned a as 10. We can apply equal to with all combinations of assignment operators as well as bitwise operators. Let us see example of plus and AND. This applies similarly to all the bitwise operators and assignment operators. Let us discuss one example with assignment operator and bitwise operator. Similarly, it applies to all the bitwise operators and assignment operators. Here a plus equal to b. A value is 10, b value is 4. a plus equal to b results in the expression a equal to a plus b, nothing but a equal to 10 plus 4, 14. So a will be assigned with 14. Here bitwise AND is applied. We have discussed the bitwise operation. When we apply bitwise operation on 10 and 4, it results 8 as the value. Coming to the special operators, we have two types of special operators, identity and membership. Is, comma, is not comes under the identity operators, whereas in, comma, not in comes under membership operators. Is the operator which is used to check whether the addresses of two variables are equal or not. It doesn't check the value of the variable. It compares the address of the variables. See, here we have taken a equal to 10 and b equal to 10. Both have same value. In Python, if variables have same value, they share the same address, which is nothing but the same memory location. Here when we print the address of a and b using the id function, id of a and id of b return the same value, which means both are sharing the same address location. If we assign b equal to 20 and run this again, you can see that address of a is not same as b. As the values are different, they will not be sharing the same address. If we again assign b equal to 10, you can see that now the address becomes same. From this we can understand that if the values of two variables are same, in order to save memory, the value will be stored in one location and both the variables a, b will point to that address location. If the value of a variable is changed, the changed variable will be assigned with a different address location. We have seen it before. Now coming to the is operator, as a and b both are pointing towards 10, their address location will be same. As their address location is same, it will return true, as a and b are sharing the same address location. Coming to the membership operator in, it checks whether the given value is present in the iterator or not. For example, here in our case, we checked for 1 in L. Here L is the list and 1, 2, 3 are the values present in the list. 1 is present in list, so it returns true. Now if we change the value to 5, now it will check for whether 5 is present in list L or not. List contains 1, 2, 3. 5 is not present in L. So when we run it, it returns false. 5 in L. It means it checks for 5 in list. As 5 is not present in list, it returns false. With this, we have successfully learned the concept of Python operators. I hope you liked the video. If you liked the video, please do subscribe my channel and press on the bell icon in order to receive notifications whenever I upload a new video. Thank you for watching my video. In the next video, we are going to discuss about Python input and output operations.